Yes.
Okay, the 1 minute. So this is the thread component, है ना? Now you can see that this is the internal undercut, and here first of all you have to find that, you have to analysis that that what is the depth of the thread, है ना? Here
Okay.
see what is the depth of the thread. What is the depth here? Depth is around 1 mm. So if
1 mm.
your undercut is more than 0.5 mm, है ना? If your undercut is more than 0.5 mm, or if the round, or round means turn of the thread is more than 1.5, then you have to go for the go with the unscrewing
Yes.
mechanism with the
Okay.
gears. Yeah, with the gears you have to go
Okay.
with the gears or the unscrewing mechanism, right? This is the condition. For example,
Okay.
if you have a component, like just for an example, like you have a component in which you have a component in which you found the rounds 1.5, okay, or below
Okay.
1.5, you can say that, है ना, which is the turn, and the depth of the overflow is 0.5, and this is nothing but this is the circle, this is a
Okay.
circular which is nothing but with the r 0.5. Is it clear?
Yes.
It is the radius. So if you found this type of condition, and if the material is PP or the POM or the PA which has a higher shrinkage value about more than 1.5 percentage, right? So
Yes.
you can use the jumping out process.
Okay.
You can use the force ejection. So into the force ejection you can use two method. First of sleeve ejection, है ना? First method is sleeve ejection. Second method is steeper plate.
Okay.
So two methods you can use in order to eject the component but forcefully, right?
Yes.
What is the what is the reason that I'm telling that material should be PP, POM or the PA? Why?
Higher shrinkage value.
But why I'm telling that I'm including only these three materials? Because it is the more flexible material, है ना? During the jumping out process it will not deform.
Okay.
It will
Understood.
not deform. That's why it is a flexible material. That's why. But if we have a material like PVC or the PC, okay, so we cannot go with this method. We cannot go
Okay.
with this jumping out method. Why? Because it's a rigid material. It's a
Okay.
quite rigid material. You can say that. So basically, if we deal with the PVC and the PC with this force ejection, it means undercut or the component can be deformed. Right.
Yes.
Okay, so that's why. That's the
Yes.
reason. So here in this component, 1 minute, in this component you can see that this is the threads, and for relieving or for ejecting this component or for relieving this threads, we have to use
Hmm.
unscrewing method, right?
Unscrewing method.
Now
Yes.
you can see that this is the core, this is the core, this is the core, and what is this? This is the cavity for this, right?
Yes.
Okay, so now you can see that here this is one of the feature which is known as interlock, but it is the part of the geometry also. See,
Yes.
it is the part of the geometry also. So here you can see that this,
Yes. Curving. Yes.
yes, yeah. So this feature is preparing this portion of the component, right? Okay, so that's why. So it will behave like a interlock, why? Because it has draft or the taper, right? That's why.
Yes.
Is it clear? Okay, one
Yes.
minute. Understood? Screen is visible? Okay.
Yes. Yes.
Okay, 1 minute. Okay. See, now you can see that this is nothing but this is the cavity portion. Okay, now you can see that what is this? Local insert. Why
Yes.
I prepared the local insert here into the cavity insert? What is the reason? Because the diameter of this pin is very less. It is around 1.8 mm. That's why. So,
Okay.
so if for example, if I have a shaft of 1.8 mm, diameter, so I cannot push this shaft of 1.8 mm diameter into this hole, right? So that's
Yes.
why I gave the shoulder. For the strength purpose, right?
Yes.
है ना. And similarly for this, that's why I have created this two local insert, है ना. और basically for example if I will prepare this feature with this core, तो can I prepare? Tell me.
Yes, sir. We can.
We can prepare, but we have to use the ADM machining for that, right?
Yes, sir. Yes, sir.
है ना. ADM machining, yes.
Yes.
But we cannot prepare by the ADM machining. Even for example, see, measure this distance here. 1 minute. I'm hiding this. Control H. 1 minute. Control H. See. See this distance from this point to this point. What is the distance here? 0.5. 0.5. So can you prepare the 0.5 insert for this? Less than 0.5. Can you prepare?
Oh, we can't, sir.
Right? So that's why we have to use this local insert method, right?
Okay.
And for the small component, this local insert is very important, right? We have to incorporate the local insert into the core or cavity insert, right?
Yes. Okay.
And now you can see that this is nothing but this is the cavity portion, and cavity insert. You can say that this is the core portion. Okay.
Core portion.
Now here I am hiding just component, and here just take the section view and see the section view. See what is happening here. Here you can see that here it is the teeth which is the part of the core. Okay.
Yes.
Which is the part of the core. So you can see that which this type of teeth we can prepare by the ADM machining. See, because it has a sharp edges. See.
Correct. Yes, sir.
है ना. So we can prepare the ADM machining for this. है ना. ADM machining for this. Is it clear?
Yes, sir.
Okay. And this core is the part of the shaft where our gear will be connected. This core
Okay.
is the part of the shaft, right?
Yeah.
Where the gear will be or the bearing will be connected, right? So there is no designing of the gear or the designing of the bearing here, right? We have to select them. Why? Because these all are the standard components, right or wrong?
Yes, sir.
है ना. So that's why we have to select that type of component. So this is the core and cavity. Now for example, now I have this, है ना. So here you can see that, for example, I'm just preparing the 4 cavity mold. Right now just I'm using mirror, right? But
Okay.
you cannot use the mirror command for this, right? Why? Because for example, if you have a thread clockwise direction, and after mirror you will get the anti-clockwise, right? That's why.
Yes.
So you cannot use the mirror. But right now for showing you, I'm just using the mirror. Is it clear? Because it is easy right now.
Yes.
So here you can see that 1 minute. This is the solid body. Select the solid body and select the specify plane. Here you can see that. है ना? Now see here. What is this? 2 cavity. I have prepared 2 cavity, for example, right? है ना?
Okay. Yes.
है ना? And 2 cavity. And here you can see that 4 cavity. 1 minute.
We can do the feature, translate feature. We can use.
Yeah, of course, we can use. Yeah, we have to use the translate feature, but right now just for showing you, for easy, I'm just using mirror command, right? We cannot use the mirror command during the design. Is it clear? है ना?
Yes, yes.
Now see here, you can see that this is nothing but it is now it will become a 4 cavity mode. You can see
4
that,
cavity
right?
mode, yes.
4 cavity mode. So here you can see that this is nothing but this 2 internal interlock. है ना? What is the purpose of these? है ना? It has few purpose. Now see, it has few purpose. This is interlock, which will be used for align the core and cavity also, right?
Yes.
Okay, so that's why you can see that I'm just taking the 1 minute. I'm just taking the sketch here, है ना? Or like this. Okay. And fix this. See. Okay. So now I am taking the, for example like 12 mm है ना, I'm just taking 12 mm or the 13 mm which is required है ना, just I'm taking the random dimension right now, okay है ना. Now see, okay, now
Yes.
extrude this है ना up to selected this face है ना, select this face or until extend until this face है ना, and click OK है ना, and give the draft also, take the draft. I am taking the draft, 1 minute, this is okay, how much draft I can take, 5 mm, okay, and click
Okay.
OK. See, understood. So why I am preparing this, any idea?
To remove.
Because on this feature 1, 2 and 3 I will create the runner portion. I will create the runner portion, that's why. Because for this component customer need auto ejection, and if customer need auto ejection, it means we have to use a specified gate system, right?
Correct, yes, sir.
And so which type of gate system we can use here? Hiding, just unite this feature with this and click OK. Now see, tell me. Tell me which type of feature I can, which type of gate I can select here. For the specific gate we have to select, right? For the auto degating purpose, which type of gate we can choose? See, this is the component, right? Now see, this is the component. Okay, now as I told you, this is nothing but, see here, like the Control H, and take the section view of this, and now you can see that this is the interlock. Okay, so as I told you, this is the feature for the runner,
Okay.
right? I'm using this feature for the runner. See here, runner like this. Okay, just see. Understood?
Yes, sir.
Yeah, so what is this? Submarine. Submarine gate system, right or wrong? है ना? So during the ejection of the component, it will be eject automatically. Or it will be degate automatically from the component to the feed system, right? मतलब component and feed system will separate automatically here, right?
Yes.
So this is the submarine gating system. I hope you understood this,
Yeah.
right?
Yes, sir. Yes.
So that's why I have created this feature. Okay, I have created this feature. I'm just subtracting this with the, है ना, you will get the female portion of this portion. See,
Yes. Understood.
right? So this is the concept, है ना, in which we are using submarine gate, for the auto degating purpose, right? है ना.
Okay.
Now if we talk about the selection of the gears, so basically here you can see that this is the 4 component. So basically we have to place the 4 shaft here, right? So here is the 1 shaft, for example. Here will be the 2nd shaft, here will be the 3rd, and here will be the 4th shaft, right?
Correct.
है ना. So you can see that, so basically, for example, if I am placing the shaft, okay, so in the center I have to take the gear also,
Yes, sir.
है ना. So for example, in the center I am taking the gear like this. For example, I am taking the gear, and here I am taking the one of the gear like this, है ना, like this.
Four parts.
Yeah, so here you can see that the selection of the gear is depending upon the position of the component,
Definitely.
है ना. So here you can see that we have to select the correct PCD for that,
Yes.
है ना. For example, if I am taking the PCD of the gear, around 45 mm, how much? 45 mm.
45.
Okay, now and here I am taking 30 mm PCD 30 mm, and here will be the 30, here will be the 30, and here will be the 30, right? है ना? But module should be same for the gear, right?
Correct.
Okay, so here you can see that. So for example, I am taking the module 1 mm 1, है ना? What is the meaning of module? Pitch diameter divided by number of teeth. It means, for example, I am taking the 45 mm pitch diameter, means it has a teeth. It has a teeth. How much? 45. That's why 45 divided by 45, right? Now, है ना? If we have a pitch diameter circle 30 mm, so it means we have and how much?
And
30.
30.
है ना? That's why we will get the 1 mm. 1 is the module, right? So module should be same for the both gear, है ना? Both gear. Okay, so this is the condition by which it will rotate to each other, right? In a proper way. This is the condition, right? Okay, so here first of all we have to select the appropriate gear. We have to select the appropriate gear, है ना? है ना? Or depending upon that position, for example, I am placing the first gear into the center and the second, third, and fourth and fifth gear at this position, है ना? So I will get this PCD. I will get this PCD, है ना? Which I am marking by the red. See, है ना? So at this PCD or at this point we have to place our component. We have to place our component. Why? Because we have to use this gear system. We have to use the gear system, right? That's why. Okay. Now see the selection of the gear. है ना? How to select the gear? See. Unscrewing mold design steps. Okay. So first of all, you can see that for the unscrewing mold design, है ना, we have to select the gear depending upon the diameter of the component. Now you can see that, for example, if we have a component and around 22 diameter or the 30 diameter, it means we have to take the more than this diameter. We have to select the PCD more than this diameter, right?
Yes, sir.
है ना? Second thing is depending upon the how much turn is required. For example, for example, this is the gear. Okay, or this is the component we have. Or component has a 3 turn. How much? 3 turn. Or if it component has 3 turn, what is the meaning of this? It means we have to rotate this more than 3.5, है ना?
Yes.
है ना? More than 3.5. It means 360 plus 360 plus 360 plus
180.
180, right? So we have to rotate at this degree.
Yes.
Okay, so that's why depending upon that we need rotation of this center gear,
Yes.
है ना? Now for example, if I am taking the 90 mm, I am taking the 90 mm of this, है ना, for this, and I am taking the 30 mm for this है ना? This is the sun gear, this is the planet gear. Is it clear?
Planet,
Okay.
yes.
Now here you can see that 30 mm. So if this center gear rotate the 360 degree, so how much it will rotate?
3 turns.
3 times.
Yes.
3 times, right? Okay, so that's why our selection will be depending upon this parameter. Is it clear? So for example, now if we have a center gear about 90 mm, so what we need? Now we need mechanism for rotating this gear, right or wrong?
Yes, sir.
Okay, so for example, we have this center gear and if we have a shaft. Now again we have a center gear. Why? And this is connected with this, and this is the center gear, and this is the center gear. This is the planet gear, and this is again a pinion, and I'm using a rake.
Okay.
Rack, and a rack and pinion mechanism I will use in order to rotate this center gear, and this center gear will rotate this planet gear, right?
Planet gear.
So basically I have to rotate this how much?
360 degree.
360 degree, है ना? More than 360 degree you can say that, right? Because how much rotation we need? 3.5,
3.5.
है ना? So basically more than 3. Now you understood that we have to rotate the 3 turn. Is it clear?
Yes, sir.
है ना? So basically we have to rotate this center gear 1 turn only.
Sir.
Okay. Now you can see that PCD. What is the PCD of the center gear? 90.
Yes.
So how to find out the circumference for this? at 2 pi r.
Okay.
Right or wrong?
Yes, sir. Yes, sir.
Yeah. For example, 2 pi r, right?
So basic, yes, yes.
Yeah, this is the basic things. है ना, तो 2 by the 2 pi r you will what you will get? You will get the linear distance. If we I break this circle from here, so you will get the linear distance, right?
Linear distance. Yes.
Yes. So I need this linear distance. Why? Because for the rack, right? Now, for example, tell me what is the 2 pi r? Tell me. 2 multiplied by 3.14 multiplied by 45.
45, yes.
Yes, tell me. Note down this, very important, right? The selection process is very important for the year.
282.
282. So it means 282. You can say that 300 mm length, working length is required for the rack.
Okay.
For the rack, right? So basically we need 300 rack, 300 working length for the rack. Is it clear? So for that, for the linear movement of the rack 300 which we need, so for that we have to select what we have to select? Hydraulic system for that, right? Now first of all we understood that we need 300 length. This is all the calculation, है ना? 300 we required. This is the 90 PCD for the center gear. This is the PCD for the planet gear, and which is all calculation depending upon the turn required to rotate, right?
Yes.
Understood?
Yes.
है ना? This is all these things, right? Now here selection, as I told you, selection of the gear depending upon the diameter of the component. So basically we have to select the gears first of all and the pitch diameter. So module should be same for the both gear, right?
Yes.
Okay. Now for example, see here. है ना? There is no difference into this. But if for example if we need more rotation, if we need only one rotation, so depending upon that we can increase the inner diameter. See,
Okay.
sun diameter, right?
Diameter, yes.
So basically depending upon that, right? Okay.
Yes, yes. Depending on turns, so we select the sun gap.
Yes. So here you can see that mold length and the mold width is depend upon the what pitch circle diameter, what is the PCD, what pitch diameter gear we are selecting, right? Depending upon that we have to take the mold length and the width. Is it clear?
Yes, sir. Yes, sir.
Understood? So in the gear mold or unscrewing mold, first of all we have to select the gears. Is it clear?
Yes.
Okay. Now prepare the multi-cavity layout design depending upon the gear selection. So we have selected the gear. So depending upon that we got the PCD. So here you can see that this is the PCD.
Yes.
है ना? PCD. Now start the mold base design using the dimension we need, right? Which we got the dimension from the gears, है ना? So we can start the designing of. But first of all we have to start the calculation. Is it clear? Now for example, initially if you will prepare the mold, concept mold. See here. Initially if you will prepare the mold for the component. For example, if you have a component like this, right?
Okay.
है ना? Now here for example I am selecting the gear for this, है ना? Just I am selecting the gear for this. Now see, है ना? This is the center gear which I am taking, है ना? This is the, what is this? PCD, as I told you, which is required. What is this?
To the planet.
Gear, right? I'm just moving this gear at this, है ना? I'm just moving this component at this location because I have to place this component at this point, right? Because we need proper location there, right? See here,
Yes, sir.
है ना? Here, see, right?
Yes.
This is, what is this?
It's a sun gas.
Sun gear, planet gear, see,
Yes.
है ना? So depending upon that we have to select all these things, right? All these things, right? Now see, just I am creating the concept right now, है ना? Just for example, just for the initial, for example, if you start the designing gear mold, so I am just creating the concept, है ना? Now see, this is the position for this, right? है ना? Now see, this is the runner, है ना, runner, just take the offset, prepare the gate. For example, I am using this. What is this?
So yeah,
Submarine gate.
that's
Yeah, submarine gate. See, right? See, it is the auto degating. It is used for the auto degating of the component and the feed system, right?
okay.
है ना? So see here, submarine gate and pattern this, right?
Yes.
हाँ, just I'm creating a simple mold, है ना, simple mold. See, है ना, तो now you can see that core and cavity. Now I will create the shaft. See, 1 minute. है ना, see, this is the complete mold base, है ना, and in this complete mold base I will not use the ejection system. I will not use the ejector grid here. Is it clear? है ना, right now I will not use the ejector grid. Is it clear? Now see.
Yes, sir.
Okay. Now
Because we are
I'm just-
using the
yes,
gas.
yes. So here you can see that this is the gear. I'm just preparing the housing of this gear at this place, right? See.
Okay.
So I'm just moving this location. See,
Okay.
है ना? See, understood?
Yes, sir.
है ना? तो initially if you deal with the you can see that if you are dealing with the unscrewing mold, so basically you will prepare this type of mold. Initially you will prepare this type of mold, है ना? So in this mold you can find a few. You can see that you can find a few errors or the mistakes. See, what is the mistake in this mold?
Part takeoff.
है ना, part takeoff or and how will operate this? How will operate this? There is no
Correct,
provision for that. See here.
Yes.
Here you can see that this is the shaft location is wrong. See, how will operate this pinion gear? Not possible.
Yes.
है ना? Okay. Here see, this is all the keys and everything, but this is not the proper way. है ना? Here we are using only one bearing in for the center gear, for the center shaft only. Okay, but here bearing required for this portion also, for this gears also, planet gears also, right? For the smooth operating, you can say that, है ना? For the smooth operation, right or wrong?
Yes, sir.
Okay, understood?
Yes.
Okay, so here, one minute. So here you can see that, see, है ना? So first of all, as I told you, है ना? First of all, what we have to select? Gears, depending upon the we have a component parameter, है ना? We have a component dimensions. So we have to select the gear first of all. See,
Yes.
है ना? What is this?
Driver. Sun gear.
No, this is not sun gear. This is the sun gear. Just for an example,
Okay.
this is the sun gear. Oh, what is this? This is the pinion, which will be operated by the rack.
Rack. Okay.
Okay. Now see,
Yes, sir.
what is this? Shaft.
Shaft.
है ना? Now what is this? Bearings.
Bearings. Yes.
Okay. Now here you can see that, है ना? This is the bearings. This is the gears. This is the again gear. So basically here will be the bearing. Here will be the bearing. That's why it will operate smoothly, right? For the complete shaft. See here, right? है ना? So this is the way. This is the way for the first of all we have to take the PCD and then we have to select the gears
Okay.
and the bearings. Is it clear?
Yes.
है ना? Now you can see that this is the cavity portion. As I told you, this is the cavity portion. See, this is the cavity portion. This is the core portion, right? Now see, this is the location, proper location, and here I'm giving the draft. See,
Okay.
I'm giving the draft. See, why I'm giving the draft? See, because this is the steeper plate. It will eject the component.
Correct. Yes. Yes.
And it will eject the component also. Okay. Now see. Understood?
Yes.
See. This is the other plate. है ना? Now see. Control H. Again. See. Quite complicated. You can try to understand. See. Here. See. this is the bearing, है ना, this is the bearing, this is the gear. So basically I have to give the provision for the bearing also here, है ना. I have to cut this, right? As I told you, it's quite complicated, right? है ना. Now see, I'm just showing the mold, okay? See, see here. See, what is this? This is the sprue, right? Sprue. What is this? This is just a concept mold, है ना, for you. See, है ना. This is the core and cavity portion, you can say that, है ना. This is the, है ना. This is the fixed half portion. Now see, I'm just hiding this plate. This is the steeper plate. This was the steeper plate, right? This is the core plate. See, core plate. Now here you can see that this is the bearing. So bearing has a provision here. See, है ना, press fit. It will be press fit. See, है ना. I'm just hiding this. Hiding this bearing. See. See, right? I'm just hiding this plate also. See, it is also a bearing. See,
Okay.
है ना. Here is the bearing again. Now see here. And for the rack, this is the provision. You can see that. See.
Okay.
Understood? Like this.
Yes,
So
sir.
we have to give few clearance. For example, from the gear outer teeth, addendum, you can say that, right? From the addendum of the gear, you have to give the 1 mm or the 0.5 mm distance for the clearance, right?
Clearance,
This is,
yes.
so this is the housing for the gear and the bearings. See.
Very good.
Okay. Now here, this is the hydraulic system which we have to use for linear movement of this.
Operating yes.
For linear movement of this, right?
Yes.
And this is quite complex, but step by step we have to design. So as I told you, what I have mentioned about the gear, What I have mentioned, first of all, analysis the
Module.
component.
Component is.
Find the parameters of the component, and the dimensions. Depending upon that dimension, we have to select the gears, shaft diameter, and bearing.
Bearings, yes.
With the manufacturing aspect. Then,
Yes.
depending upon that selection, we have to prepare the multi-cavity layout of the component.
Okay.
Okay? Multi-cavity layout, and then start the designing of mold base. Before start the designing of mold base, we have to complete this calculation.
Yes.
Right? Understood? I think it was quite complicated, right?
Yes, sir. But concept is understood.
Concept understood? Okay, concept should be clear. Is it clear? For the reference purpose, I will share you this mold also. Okay?
Okay.
Understood?
Yes.